Chapter 2.2, let's look at the leading coefficient test. We're going to look at when n is odd, when the degree is odd, and then also when it's even, and then break it down to a little bit more when it's a positive leading coefficient versus a negative leading coefficient. So first we'll take a look at when the leading coefficient is positive. So an example of odd and positive is 2x to the third power. Okay, we're just looking at the leading coefficient. So generally what this graph looks like is it will go left here, go down on that side or up on that side, and does something in the middle. Doesn't matter what it does in the middle. So we can describe this as it rises to the right and it falls to the left. And actually, we read it from left to right. So we would say it falls to the left and it rises to the right. More specifically, we can say that f of x approaches infinity as x approaches infinity. Then on the left side, we can say f of x approaches negative infinity as x approaches negative infinity. Now let's look at when the leading coefficient is less than 0 or when it's negative. So an example of that would be like negative 4x to the fifth power. So it's reflected when we have a negative in the front. So it goes up on that side, down on the other, down on the right. Maybe it does something like this in the center. And so we can say that it rises to the left and falls to the right. And we know that as f of x approaches infinity on this left side, we know that our x value approaches negative infinity. Okay, so again, just our y values are increasing. It's going up to positive infinity as our x values approach negative infinity. To this right side, we know that f of x is approaching negative infinity as our x values approach positive infinity. Okay, so odd, they go in opposite directions. When it's positive, it rises to the right, falls to the left, and then when it's negative, it rises to the left and then falls to the right. Odd, opposite. When n is even, we're going to think that they go exactly the same direction, or remember that they go exactly the same direction. So a sub n is greater than 0. So let's look at when it's positive. So an example of that would be maybe 3x to the fourth power, so it's positive, and we have the power of 4. Let's say that our graph does something like this. It goes up, and then it does something else in the center. Okay, something like that. And we know that it rises to the right and left, rises to the right and left, or left and right. And then how we would write that in this form, f of x approaches infinity as x approaches infinity, and then f of x approaches infinity as x approaches negative infinity. Let's do a sub n less than 0 for when n is even. So an example of this would be, let's say, negative 1/5 x squared. So the graph does something like this. So they go exactly the same direction. So we say that it falls to the left and right. Then we could say that our y values, f of x approaches negative infinity as our x values also approach negative infinity. On the right side, f of x approaches negative infinity as our x values approach positive infinity. So the leading coefficient test just has us look at what's called end behavior. And so hopefully you remember this from Algebra 2 last year, but it's the same thing. So I'm hoping you remember that, right? So again, as the degree is odd, you know that it goes in opposite directions. If it's positive, it goes up on the right, down on the left, and then up on the left, down on the right. When n is even, they go exactly the same direction. So it's positive, the ends both go up. If it's negative, the both ends go down. So let's apply the leading coefficient test. We just have to describe the left and right-hand behavior of the graph of each function. So for the homework, it's just going to have you to describe it. So we have negative x cubed. So all we look at is the leading coefficient. We know that it is odd degree and it's negative. So it'll look something like this. So we know that it rises to the left, and falls to the right. I will want you to describe it, though, by using f of x. F of x approaches infinity as x approaches negative infinity. And then on the right side, f of x approaches negative infinity as x approaches infinity. Okay, and again, I use this little sketch here to help me out. So the next one, x to the fourth. So we know they're going the exact same direction, so they both go up and up. It's even with a positive leading coefficient. So this rises to the left and right. Or we can say that f of x approaches infinity as x approaches negative infinity, and f of x still approaches infinity as x approaches infinity. For the last example, that's an x to the fifth, so it looks something like this. So it falls to the left, and rises to the right. Or f of x approaches negative infinity as x approaches negative infinity. F of x approaches infinity as x approaches infinity. So you could try these examples here if you'd like. You can pause the video and I'll give you the answers when you come back. So the first one, it is odd positive, so falls to the left, rises to the right. And then on letter B, it rises to the left and falls to the right. It's negative and still odd. Note that the leading coefficient test only tells whether the graph eventually rises or falls to the left or right. It just tells us end behavior. You must use other tests to determine other characteristics of the graphs, such as intercepts and minimum and maximum points. Hope this helps out. Thanks for watching.